Okay, so the next one is we've got a glass block. We're going to shine at an angle of 25 degrees from the normal, draw a ray diagram to show both the reflected and the refracted ray. So many students miss out the reflected ray because they forget that a glass block will still reflect some light. So our first job is, well, let's just start with a glass block. So there's my glass block. Then I've got to draw the normal. The question's saying, well, put a normal in. So dashed line going through the block. The next part now is you'd get your protractor and you'd measure an angle of 25 degrees and shine that in. So we're making sure that this is 25 degrees. I've no idea what that angle is. Then if we were to imagine behind here, I've got a car, side A, side B. Side A is going to hit first, so that's going to slow, and then we're going to end up with this being refracted towards the normal. That's the first part. We've got another, whoops, apologies, let's get that there. We've got another normal line here where the ray is coming out of the block and meets the new boundary or the new interface. And what I've got to do is make sure that the ray coming out is parallel to the ray coming in. So I'm going to do it by eye, and that's roughly right. Now I haven't done this. Please make sure you use a pencil and a ruler. Okay, so that's that part. Well, we haven't fully answered the question because now we've got to draw the reflected ray. So that's the refracted ray drawn, and the reflected ray is really easy. We know that the angle of incidence equals the angle of reflection. So if that's 25 degrees, I'm going to measure 25 degrees from here, and those two angles will be the same. Now it says here, draw to show, well, clearly I've not labelled it. So this is the refracted ray. This is the reflected ray. In fact, that's bugging me because that's in blue. So let's put that in blue. There's the refracted. So I hope that makes sense. So it's quite an easy question, to be fair, but it's just making sure you add the reflected ray. Next part, it says describe a practical procedure to prove the law of specular reflection. So that's what we've just done. This is specular reflection is from a plane surface or a flat surface, such as a mirror. And we know the law, theta I equals theta R. So to just go over this practical that you'd have done loads of times down in year 9, get a piece of paper. Oh my days, that's terrible. Get a piece of paper. It's mildly better. So I'm just going to label that as grab a piece of paper. Next part, get a mirror. Put it on your piece of paper. With a pencil, draw in front of the mirror, hash behind it. So here is our mirror or flat surface. The next job is we're going to measure 90 degrees and draw a dashed line for the normal. And that's because we always measure the angles from the normal. Next part now, we're going to need a protractor. And we're going to need a ray box. So I'm going to use the protractor first, and then I'm going to draw lines 20, 40, 60, 80. I know that's not perfect, but just pick some angles. So we're going to draw some lines. This is the incident rays, and you can pick 10, 20, 30, 40, 50 degrees and so on. Okay. Next job is we're then going to get the ray box. So if I just change that colour there. So I'm now going to get a ray box, and I'm just going to now get that ray box and shine it along this line. There we go. And I'd say that in terms of how we do this. So let's get the ray box, shine it along 10, shine it along 20. Now when we shine it, we'll then have a reflected ray. What we don't do is get a pencil and just do a rough sort of sketch of it. We do an X and an X, and then we draw the line with a pencil and a ruler later. So again, we put it on the next one, X, X, and we draw that line, if that makes sense. So we'd then use X's to mark the reflected ray. So if I get rid of all of this now, try to put this into words. Remember, if you're ever stuck on an exam, just draw a picture, you're going to get marks for it. And lots of the times the exams will say use a diagram if you wish to help your explanation. I'm just going to model this now with words. So here we go. I'm not going to do full wording though. Grab a piece of paper, grab a mirror, put it flat to the surface, pencil to mark the front. There we go. And that if you go back on the video, you'll see me drawing all this out. So grab a piece of paper, mirror flat. Next part, get a protractor, and then draw at 90 degrees the normal, and then using your protractor mark 10, 20, 30, 40, 50 degrees from the normal. So next part now, get a ray box and shine along that path. And the last part, mark the X's along the line because the ray will be on the paper for you, and then draw the ray with a pencil and a ruler. That's it done really roughly. So that helps in terms of light.